this. Let's continue with the explanation. So while a force may cause one or more of these effects, it is important to remember that none of these actions can take place without the action of a force. Remember? So if the force is not there, shape will not change. If the force is not there, the direction of the object will not change. If the force is not there, then the speed of the object will also not change. Okay, so nothing can take place without the action of a force. Thus, an object cannot move by itself, it cannot change speed by itself, cannot change direction by itself, and shape also cannot change by itself. Okay? Now we come to a very important topic, that is contact forces. Okay, contact forces means when you have contact with the object and apply a force, then only the change in shape or change in direction or change in speed will occur. That means you have to touch the object. Suppose there is a table, you have to push the table. Okay, then only the speed of the table will change. Okay, the direction also might change. Okay, so that means if there is no contact, then the speed or the direction of the object will not change, or the shape will also not change. Okay, so the first example for contact force is muscular force. Generally, to apply a force on an object, your body has to be in contact with the object. The contact may also be with the help of a stick or a piece of rope. Okay, not necessary that you have to touch the object. Okay, you can also touch the object with the help of a stick or even with the help of a rope. Okay, but there has to be some kind of contact. So this force is caused by the action of muscles in our body. The force resulting due to the action of muscles is known as muscular force, isn't it? Definitely. So this force is caused by action of muscles. Suppose you want to push a table, or you want to pull water from a well, okay, or you want to play cricket. So what you have to do, you have to use your muscles. Okay, you have to spend your energy, then only something will happen to the object. Okay, so if you use your muscles, if you apply your strength, then only water will be pulled out of the well, right? So if you apply your full strength and hit the ball with the bat in cricket, then only your ball will go for a 6 or for 4 runs, isn't it? That means you have to spend your muscular energy, then only some change will happen to the object. Okay, so this particular force is called muscular force. So animals also make use of the muscular force to carry out their physical activities and other tasks. Animals like bullocks, horses, donkeys and camels are used to perform various tasks for us, isn't it? So animals, like earlier times also, when there were no transportation available, so people used to carry their goods on the back of the animals, isn't it? Like horses or donkeys or bullocks. Okay, they used to carry heavy loads for us. So what kind of force they were applying? Muscular force. Okay. Since muscular force can be applied only when it is in contact with an object, it is also called contact force, isn't it? So without touching the rope, water cannot come out from the well, isn't it? So without hitting the bat with the ball cannot go for a 4 run or for a 6 run, isn't it? That means there has to be a contact with the object. Okay, that is why it comes under a contact force. Okay, so this is an example. See how on the back of animals, okay, things were getting carried. This is hay, okay, getting carried. You can see the person. So the animal is applying what kind of force here? The animal is pulling the cart. So definitely the animal is applying muscular force here. Okay, so this is an example of a muscular force. Okay, so now very, very important topic, that is friction. Okay. A ball rolling along the ground gradually slows down and finally comes to rest. So have you seen this? Suppose a ball is rolling on the ground. You don't do anything to the ball. Okay, I'm not saying you go and touch the ball or you make the ball stop. You just observe the ball. What will happen after some time to the ball? Automatically it will come to rest. Okay. A car or a scooter also comes to rest once its engine is switched off, isn't it? So those who you have seen your father or mother drive the car. Okay, so when the engine of the car is stopped, the car also stops, isn't it? Similarly, a boat comes to rest if we stop rowing it. So boat, what we have to do to make it move? We have to row the boat. So once we stop rowing the boat, what will happen to the boat? It will come to rest. Okay. So in all these situations, no force appears to be acting on the objects, yet their speed gradually decreases and they come to rest after some time. That that means on their own, they come to rest. Like the ball moving on the ground, you are not doing anything to the ball, it comes to rest. Okay, so when you just switch off the engine, it comes to rest. Okay, that means automatically the objects here are coming to rest. Okay, so the force responsible for changing the state of motion of the object in all these examples is the force of friction. Okay, so what is happening? This is called friction. Okay, friction is a kind of force, but we cannot see friction. Okay, that is something that comes into action. Okay, it is a kind of force which acts on the opposite direction. Remember, frictional force always acts on the opposite direction of motion of the object. Okay, suppose the object is moving in the forward direction, frictional force will act in the backward direction. Suppose the object is going towards east, frictional force will act towards the west. That means in the opposite direction the frictional force acts. Okay, so it is the force of friction between the surface of the ball and the ground that brings the moving ball to rest. Similarly, friction between water and the boat brings it to stop once you stop rowing. Okay, so what is happening? The ground where the ball is moving, that ground is what? It has lots of irregularities. No ground is 100% smooth. Always there will be some kind of irregularities. Okay, so this irregularities between the surface of the ball and the ground is making the ball come to rest. Okay, similarly the irregularities of water and the surface of the boat touching the water is making the boat come to rest. Okay, so the force of friction always acts on the all moving objects and its direction is always opposite, remember, to the direction of motion of the object. It is always opposite. Since the force of friction arises due to contact between surface, it is also a contact force, isn't it? That means suppose the ball is moving in the air also has friction. Okay, suppose the ball is moving in vacuum, there is nothing. Okay, so you will see that the ball might not stop moving. Okay, why? Because there is no force here. Okay, so remember that frictional force also, you know, it's a kind of force that is resulting due to contact between the object. Like when the ball is moving on the floor, okay, the irregularities of the floor is making the ball stop. Okay, that means it is coming in contact with the floor, then only the ball is stopping. The ball doesn't stop on its own. Got it? So that means this frictional force is what? It is a kind of contact force. Okay, so we'll continue with the explanation in the next slides. Thank you.